First, the problem. Let's look at the selection problem. So let me describe. Although we have seen many versions of selection problem, right? Find the minimum, remember, find the minimum, find the median, some special cases, find the median. So we did actually three. Strictly speaking, we did three special median problems. So let me give you what are those three. Okay, the median problem for 3-element array, right? So that's one. Median problem for 4-element array, the second largest or smallest. We did a little bit in our exercise or homework. And we did the median problem for 5-element array, right? So the median, special cases. But in this unit, we will solve the general selection problem, including the general median problem. All right, so let's start with the problem statement. Our problem number 15. Given an array and a positive integer k. Positive integer, okay? Yeah. How to find the kth smallest element? Similarly, the kth largest, the same way. Yeah. So let's just use the smallest. Okay? Yeah. That's the problem statement. Here we have a name for this kth smallest element. So we call it kth order statistic. So one special statistic, kth order statistic. Okay? Sometimes we can also refer to this element with rank k. It has rank k. So in our discussion, we may need to use these terminologies. All right, next, let's do analysis. First, let's look at our data, the data given in the array. But we know this array is unordered. You cannot use the order information to solve this problem. So it is unordered. Okay. Then, next question, we tried before, if you recall our unique element problem, you may ask this question: should we sort the array first? Because in our unique or element uniqueness, the element uniqueness problem, we sort our array first in that one. But here the situation is different. So if you want to sort the array first, you do too much work. Okay? So why? The cost of the sorting is theta of n log n. Thus, okay, you may ask me why it is this, this growth function. The general sorting algorithm, the overall performance is in this category. How do you know it? Right? So you may ask me this: how do you know it? So here at this point, I didn't give you that solution yet, but in my lecture number 7, you will see this answer. Okay? So you will see this answer, n log n. How do we get n log n? Okay? For the average case efficiency. Yeah. All right, so now let's use this number first. This efficiency function is still too high, we don't want to pay this much cost. Okay? We want to pay less than this. Yeah. Think about for the minimum number problem, minimum, find the minimum. For the minimum number problem, our solution is n minus 1, right? So the cost we like to pay is big theta of n, not big theta of n log n. That's a lot of improvement. So that's why we need to find a different solution. The solution should not be based on any sort. Okay? Yeah. So that's the idea. Yeah. Next, let's look at the solution directly. How do we divide the problem? Yeah, because we know divide and conquer, this is the most commonly used problem-solving method for our computing problems. So the question is, how do you divide the problem? So that's not easy. Yeah. So for this problem, we need to do that. All right. Divide the problem. Okay. To divide a problem, you need to have some strategy. Yeah. So here, let's look at our strategy. Okay. In order to divide the problem into two subproblems, yeah, so how? So that's a big question mark. Okay, so this is still a big question mark. Later we need to work on this. Okay, let's assume we have that. So we divide the problem into two subproblems. Then we can drop one of the subproblems. We can drop one of the subproblems. Why you can drop? Sometimes you can drop, sometimes you cannot drop for the general computing problems. Okay. Sometimes you can drop, sometimes you cannot. Fortunately, for our selection problem, we can drop. Okay. Later, for sorting problem, we cannot drop. Okay. We cannot drop. Okay, so you can see the difference. For selection problem, we're lucky. We do not have to solve all the subproblems. We only need to solve one of the two subproblems. But for sorting problems, we need to solve both subproblems. So look at the difference. Okay, all right. Let's continue. Yeah. Convert the original problem to one of the subproblems. Convert original to one of the subproblems. Yeah, because so here the reason we do that, yeah, actually it should be convert, yeah, actually should be the other way around. It should be convert the subproblem to the original problem. Yeah, it should be like this. Okay, yeah. So I will change this line. Convert the subproblem to the original problem. So why is that? Because we want to do recursion. 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 We want to do recursion. So for the original problem, you have a function. After we get a subproblem, we call the same function but for a smaller array. So that's the recursion. Yeah. So that should be the other way around. Okay? All right. What do we need to do if we want to do the conversion? Yeah. So let's see. We we need to convert the kth order statistic to appropriate rth order statistic if necessary. Okay? So here let me use if necessary. Why is that? Because sometimes we need to convert. Sometimes we do not need to convert. So here I put this if necessary. Okay? All right. I will give you the, more information for this step. We will see in the next slide, we will see this. Okay? Yeah, we will see this partially, right? Yeah, not completely, partially. Okay? Yeah. Because more details we will see, in remaining part of the lecture. Next, we look at the implementation. How do we do the implementation? Yeah. All right, so we still use the elimination method. We want to eliminate one of the subarrays. So the question, how to eliminate a subarray? That question, more details we need. How to eliminate a subarray? Okay. So next slide, I want to explain how to eliminate the subarray. Okay. Let me draw a diagram. So in this diagram, suppose we need to find the kth smallest element. Okay, all right. So we have two cases here. So think about, so here, let's view this problem in two different ways. Okay, all right. So the first way, eliminate from the left end. When you do elimination, sometimes you need to eliminate the subarray from the left end. So this end. Okay? Yeah. So the remaining elements, you need to do recursion call. Okay? And sometimes you need to do elimination from the right end. Yeah. Because you drop the right subarray. Okay? So these two cases, yeah, from the left end and from the right end. So if you view this problem two different ways. Okay? All right. And if we view these two different ways, the kth smallest element is also the x largest element. Okay? So this element has two rows. One kth smallest, another x largest element. Same thing. Okay? Yeah, but what is the relationship between k and x? What is the relationship? Okay? Yeah, so here let me do a chart to answer this question. Smallest, largest, the correspondence. All right. When the rank number smallest equals 1, the largest number equals n. Okay? The first smallest is the nth largest. That's the meaning. Okay? How about the second one? Okay? The second smallest equals the n minus 1th largest. Right? And so on. Here we do this. We use our frequently used method using the invariant. What is the invariant? So here we can find the invariant. Yeah. So let's look at another one. The nth smallest, that is the first largest. Okay? So we have that invariant at this point. Smallest number plus the largest number. S plus L. L S means the smallest rank, L means the largest, from the larger side. L rank, S rank. All right? So S plus L, that number equals n plus 1. That is the invariant. Okay? So we can look at the general case. For the kth smallest, what is the x number for the largest? The sum x plus k, or k plus x equals this number. So you can find x. X equals n minus k plus 1. Okay? So in this way, we can view this problem from two different sides. Sometimes we need to use a different view. So that could help. Okay? Yeah. All right. So that's the introduction part. Okay. C.2. Yeah. So I stop at this point.